Hello everyone, welcome to Lab 2 Experiments. Today we're going to study experiment number 8 in machine health monitoring section, and this is harmonics. So what's harmonics? Harmonics are electric voltages and currents that appear in the electric power system as a result of certain kinds of electric loads. To define harmonics, it is components of a periodic wave with frequencies that are integer multiple of the fundamental power frequency. So if I go to page 2, I have a sine wave. Sine wave in time domain is going up and down with some amplitude, up and down, up and down. But in the frequency domain, you will find that the sine wave has only one frequency, the fundamental frequency. This is the fundamental frequency of a normal sine wave. But in case of the presence of harmonics, in this case, we will have some distortions of the sine wave. So in time domain, instead of seeing smooth and normal sine wave, you are looking at some signal but with distortions. And in the frequency domain, you will see that the main fundamental frequency plus other frequencies, and those are the harmonics. What is the values of these frequencies? It is multiple of the main fundamental frequency. So if this is 3, you will find another frequencies at 6 and 9 and 12 and so on. So going back to the definition, harmonics are components of a periodic waveform with frequencies that are integer multiples. You will not find something random, it's multiple integers. So 3, 6, 9, 12 and so on of the fundamental power frequency. Good. A pure sine wave without any additive components will have a frequency spectrum of similar to the one shown below. So this is pure sine wave, and this is sine wave with distortion of harmonics. It is highly recommended to monitor harmonics because very often the operation of the electric equipment may seem normal, but under certain combination of conditions, the impact of harmonics is accompanied by damaging results. And that's why for today we want to study harmonics and how to monitor our system. Good. So in terms of equations, we need to find something called the total harmonic distortion, or THD. It is a measure of the distortion caused by the harmonics in a voltage or current signal. So if the signal has originally an amplitude of I1, current signal for example, with I1 amplitude, to calculate the total harmonic distortion, we need to find out the first amplitude, or the amplitude of the fundamental frequency, and then in the numerator we will have to write down all frequencies, the amplitude of all other harmonic frequencies, I2 square, the second harmonic, I3 square, the third and fourth and so on. So all harmonics together divided by the amplitude of the fundamental frequency, and this will give us the value of total harmonic distortion. If I want to find the RMS value for the new signal, it will be the original RMS value of the first original signal multiplied by this factor, which is affected by the total harmonic distortion. Good. So let's go and perform our experiment. We need to go and open the machine health monitoring software and select experiment number 8 for harmonics. So this is experiment number 8, harmonics. We have two tabs, one for voltage and other for current. Let us start by voltage. Now we need to run the machine. It's the DC motor. We need to run the machine on speed 5 and observe the voltage and current frequency spectra. So if I run the machine, let me look in here. At position 5, it's ready at 5. You see that we have the voltage, the fundamental frequency in here with amplitude of almost 50. But again, we have another frequencies 1, 2, 3, 4, multiple of the fundamental one. So 1, 2, 3, and we have other 19 frequencies generated by harmonics. So as I mentioned earlier, we will have the fundamental frequency and multiple of that depending on the numbers of harmonics available in the signal. Our experiment basically will be recording the voltage and current, so two sections, one for voltage and other for current, and we need to write down all frequencies. So the original frequency, it has an amplitude, I remember it was 50. The first harmonic, some amplitude, second harmonic amplitude. So we write down all amplitudes of all frequencies, the 19 frequencies, and then go back and use the formula to calculate the total harmonic distortion as a percentage. So this is our task for the experiment. Same thing, if you are done with the voltage, we will do the current side. So again, we have another table for current, and if I run the system, I go to current this time, run. So I have the amplitude of current, and I will be able to measure the values of the fundamental frequency, and it is amplitude, and same thing for other harmonics. If I'm done with that, I will be able to calculate the total harmonic distortion for voltage and also for current. Good. So let me do that again, and I will make the screen very clear for you to be able to capture the values of frequencies. So this is for voltage, and run. I can control this. So this is maximum of 60. So you can take a screenshot for voltage, and same thing we can do that for current, which is maximum of 0.32. So now you will be able to write down the values in the table and calculate the total harmonic distortion for both voltage and current. When I calculate the values of total harmonic distortions percentages, there is some standards given by IEEE. The values of the voltage total harmonic distortion that are below 5% are considered acceptable, while the values that exceed 10% are definitely unacceptable, as the high total harmonic distortion may cause problems for sensitive equipments. So we will be able to recognize the total harmonic distortion and see if it's acceptable or not. In our machine, in our experiment, when we calculate the total harmonic distortion, we have the icon to check the value. If it's correct, you will get this. If it's correct, this number will be green. If it is wrong, it will be red, as we see in here. So this is our experiment for today. Thank you very much.